Hi, I'm Tom Brule from the St. Charles Municipal Electric Utility.
My name is Lieutenant Jeff Terrell with the St. Charles Fire Department.
And today we're going to talk about solar voltaic systems and how they interconnect with the electric utility grid.
We're also going to discuss how these systems can pose hazards to first responders. All right, Tom, we've brought everyone out here to the Altorfer Caterpillar solar plant here in St. Charles. Why don't we go over how these systems work?
Okay, the first basic element to cover is the difference between alternating current and direct current. Alternating current is what we commonly know in our homes and businesses to power most of our devices. Direct current is a single path flow for current, and it's typically associated with batteries, everything from the small batteries to large car batteries.
Because we have both of these types of electricity in the system, what we need is an inverter. Let's go check one out. Okay, Tom, we're underneath the solar panel here at the inverter. I can hear buzzing from the electricity. Is it a problem for us to be this close?
No, there's no hazard at this point. The inverter is just making that sound as it converts the direct current to the alternating current. Here underneath, what you're seeing is the wiring that is carrying the DC current through this collector box into the inverter, where again, it is transforming the direct current into alternating current, and the alternating current is going out onto the grid.
So as you can see, we're perfectly safe here under normal conditions discussing this with you, but the reason we're here today is things can and do go wrong. So let's discuss some of the problems that can occur with these systems and what to do about it when they do happen.
The hazards of direct current are similar to that of alternating current. Shock and arc flash are risks that one encounters with the cables, panels, and equipment related to solar power systems.
When responding to a call involving solar panels, the first thing you want to do is interrupt the power. For a small residential system, there should be a main disconnect shutoff present. Otherwise, call your local electric utility and they can pull the meter to interrupt the power. On a large system such as this, we have an emergency shunt trip that will kill the power for this system.
Disconnecting the solar array from the electric utility system is an important first step. That's because when the inverter senses the loss of the alternating current from the electric utility grid, it will stop transferring DC to AC, and the entire AC system will become de-energized. By doing this, you've removed at least half of the hazard.
Even if you've de-energized the AC system using the shunt trip or the main breaker for a residential system, DC power will still be present. Obviously, on a bright sunny day like today, the solar panels are making DC power. But even on a cloudy day, if the sun is out, if it's daytime, we're going to have DC power present in those cables we discussed earlier. The only thing that you've done is cut the AC power from the inverter to the system. If interrupting the DC power is necessary, on small systems such as residential systems, you could put a blanket or a tarp over the solar panels to interrupt the photons from touching the panel. On a large system such as this, doing that would be impossible. So just realize that there will always be DC power present.
One common thing that could occur is an electrical fire related to some of the equipment from the solar system. So in this case, if this is an alternating current panel, if this were to be arcing and sparking and on fire, the proper procedure would be to de-energize the alternating current source and then keep this fire from spreading.
This equipment is already destroyed at that point. If you do have fire on the ground, fire in the grass that is spread from this, one thing that you can do now that the AC power is disrupted is you can stop the spread to other locations where more expensive equipment that hasn't been involved is present. One thing that is a bigger problem with residential systems, unlike here where we just have grass that may be the exposure involved, the residential systems are usually on the roof on top of a structure. So if you have similar problems with the arcing and sparking on the roof, the whole structure would be your exposure at that point. As we discussed earlier, killing the AC power is going to be your first step. After that, you can put out the fire as normal. Just remember that the panels will still have DC present. One other scenario that we would find is if there are people present in the solar field over here. Now, if somebody snuck over the fence and came in and maybe were injured in here, or if a worker was present and injured, we as the fire department could come in and we could assist that person and it would be perfectly safe. As you can see now, you can touch the panels and there's no electrical hazard that they pose. You really wouldn't even need to de-energize anything in the system to be able to come in here safely, assist a person.
Now, on the other hand, should a worker or another person be injured and involved or engaged in any of the electrical equipment or panels, obviously we would need to make the scene safe by starting with de-energizing the AC before we came in and started treating.
One benefit we have here in the city of St. Charles is the fire department and public works work so closely together and work so well together. One example is these signs that the public works department made in conjunction with the fire department.
So in this case, here is the shunt trip button that would de-energize the AC. So we've clearly labeled it, and that we've also reminded first responders that only the AC voltages are going to be de-energized by pushing this button.
Now at the other access points here in the facility, they are labeled with different signs with the hazards that are present and also with emergency contact information 24 hours a day for this particular plant. Now I would encourage you to work closely with your municipality, with maybe private owners that have facilities such as these, or even residential occupancies that would have solar panels on the roof, to work with them to document and label things like emergency shunt trips and other hazards that are present with solar equipment.
The basics of solar voltaic systems is simple. The sun hits the panels create DC, DC goes into the inverter creates AC, and then that flows back onto the grid.
In closing, first responders need to remember these things. Isolating the inverters from the electric grid will cause the inverters to stop creating AC from DC. Even with the AC de-energized, if it is daytime, DC voltage will be present. Roof-mounted systems create new hazards for fire response.
Other things to consider when responding to a call involving a solar installation. First, disconnecting the system from the utility will normally stop power at the inverter, but there are self-source systems which can continue to operate when the utility source is removed. Second, assuming the source to the solar installation is the utility, disconnecting it will normally cause an inverter to cease to energize, which does not necessarily imply open contacts anywhere. Inverters can simply stop gating or converting DC to AC while remaining electrically connected just as before, putting all your trust into electronics. Look for a disconnect switch and make sure it is locked and tagged out before considering it to be de-energized for firefighting purposes.
We hope you learned something new about solar panel systems watching this training video today.
And we would like to thank the Altorfer Caterpillar for letting us film this in their plant, and I'd like to thank the St. Charles Fire Department for their participation.